Voltage, current, and resistance are basic quantities in all electrical circuits. They are important because every circuit design, implementation, and troubleshooting revolves around them. In this video, we are attempting to make them clear to you, and hopefully we will. Points to be focused on include voltage, current, resistance. We will talk about the resistor, voltage sources, and the basic electric circuit. After this video, you should be able to explain the concepts, state simple formulas to back them up, and give their units. You should be able to use voltage, current, and resistance to describe a simple circuit. From basic physics, we know that like charges repel while unlike charges attract. We are using this simple concept to explain voltage. In the figure here, we see two charges attracting. If we let them free to move, they are going to move together and touch. Now we want to move them some distance apart. To do that, some work needs to be done. Let's do that. We move them apart and set some kind of barrier in the middle so they won't be able to come back together. Like charges have a natural tendency to attract, and they will tend to move together but won't be able to because of this barrier. It is this tendency they have that we call voltage in electricity. Voltage is expressed in volts. Mathematically, voltage equals the amount of work we have done while moving charges apart divided by the number of charges we have moved. Voltage in volts work in joules and charges in coulombs. Now we want to have some path for charges. We create an opening in this barrier, and because of the potential energy charges have, they are going to move from B to A. A is fixed here. The number of charges that pass through this section of opening per unit of time is called current in electricity. So current equals the number of charges divided by time. Time in seconds, charges in coulombs, and current in amps. Another good way to understand current is to think of it as a flow of charges. Now we focus on the material these openings are made of. Some materials make it easy for charges to pass. When this is the case, the movement of charges is fast, and we say that the material is of low resistance. Excuse me. When the material makes it hard for charges to pass, the movement of charges is slow, and we say that the material is of high resistance. Resistance is expressed in ohms. And in practical circuits, we use a device called resistor to achieve resistance. In these circuits, we use these symbols to represent resistors. Voltage sources are devices we get voltage out of. It is inside these devices that happens the great work of moving charges apart and barrier introduction. We move charges apart, and we get voltage between the two terminals of the voltage source. In circuit schematics, voltage sources are represented by these symbols. We have two symbols for DC voltage sources and one symbol for AC voltage sources. You don't need to worry for DC and AC voltage terms now. All you need to know is that they exist. A circuit is an arrangement of physical components that use voltage, current, and resistance to achieve some goal. It is composed of a source, which is the voltage source here, the path for current, and the load. In circuits, loads are energy-consuming devices. The function of this circuit is to light this bulb. When we push this switch, we get light. Now you may ask, how do I apply voltage, current, and resistance concepts to this circuit? The voltage source is providing voltage between its two terminals. Wires usually have some resistance to current, and we have current flowing through this wire. Now comes the time to talk about two simple but important concepts in circuit design. Short circuit. Short circuit is a term we use to mean that current is going back to the source without passing through the load. Short circuits cause overheat, and devices in the circuit loop may be damaged by excessive heat buildup. So keep in mind that they are bad and should be avoided in any circuit design. Open circuit is when for some reason the circuit loop has been broken and there is no way for current. Because there is no current, the circuit simply does not work. Since we have covered too much already, a recap wouldn't be a bad idea. Voltage is the potential that charges have to move. Current is the flow of charges. Resistance is the opposition to current. Resistors are devices we use to achieve resistance, and they are rated in ohms. Voltage is in volts. Current is in amps. A voltage source is a device that provides voltage. An electric circuit is an arrangement of physical components that achieve some functions. I hope this has been informative to you, and I'd like to thank you for viewing.